Continuing in lesson 3-4, we're looking at modeling linear relationships. So page 185, example 2, the cost to manufacture 5 toys is $17.50. The cost to manufacture 10 toys is $30. Construct a linear function in the form y equals mx plus b that represents the relationship between the number of toys produced and the cost of producing them. So in order to get our equation, this y equals mx plus b, two things we have to have. We have to have the slope, which is m. We have to have the y-intercept, which is b. So the first thing we can do, they didn't write it this way, but we actually know 2 points that we can figure out our slope. They said 5 toys is $17.50. So that's like 5, $17.50. 10 toys is $30. That's like 10, 30. Okay. That makes the y be the cost of the toys. If we make that on the y-axis, we can see the change in the cost of toys, which is probably what we're interested in. You know, do we have enough money to buy this many toys, maybe? Okay, so if we label the x and y there, remember slope, or rate of change, is change in y over change in x. So they started out 30 minus 17.5. And we have to be consistent here. If we started with the 30 for the y, we have to start with the 10 for the x. So for the x's then, they did 10 minus 5. So they got 12 and 5/10 over 5 divided out is 2.5 over 1, which is the same as just 2.5. We would actually probably, if you guys had calculators, just divide that and you'll just get 2.5 there. Okay, so that is our slope. Now, the book doesn't get into this, but the slope, they could ask us what that means for this problem. What we'd want to think about is what's our y and what's our x. Well, the y was our cost in dollars. So kind of going back to when we did rate of change stuff, first of all, we could say this is positive. Since it's money, we could put a 0 behind it. It's dollars. And our x represented what? Good. X is the number of toys. So when we divided that, we divided the dollars by the toys. So what that means, they didn't ask us, but basically we're saying it's $2.50 per toy. That's what our rate of change is telling us here. Okay, so that's our slope. Now we've got to find the y-intercept. In order to find the y-intercept, we're going to use the slope that we just found and one of our points. It actually does not matter which point we use, and I will prove that to you here. They used the point 1030, which is a good choice. There's no decimals or anything there. We will use the not so nice 5 and $17.50. Okay, so this is just showing to you guys that we'll get the same y-intercept if we use this other number. So m is 2.5. If I use the 5/1750 here, make sure you substitute in the right spots. The x is 5. The y is the $17.50. And we don't know what b is. That y-intercept, we are trying to figure that out. Okay, so again, it's just substituting in our slope and substituting in either one of those points, whichever one you like better. Okay, we can simplify this a little bit here. Over on the right side, 2.5 times 5. Should be $12.50 or 12.5. And then if we were going to solve this for B, what would we have to do? We're going to get that B by itself. Subtract. Good. They're adding, so we subtract. And that comes out to a 5. So remember, B is our y-intercept. So our y-intercept is 5. We already said our slope is 2.5. So that means that our equation, like I said, is y equals 2.5x plus 5. And you'll notice the book didn't show all the work they did because they don't want you guys having a 1,000-page book or a 2,000, 5,000-page book by showing every single step they do. But notice they got the same y-intercept value that we did. The y-intercept, that's our initial value again. So, you know, maybe we've just got a $5 startup cost somehow for getting the line set up for producing these cars, whatever that might be. If we look at the try it, they're tracking how much food they feed their dog each week. And again, they don't list it this way, but we could make the information they're giving to us as ordered pairs. So 2 weeks they've used 8.5 cups of dog food. After 5 weeks they've used 21 1/4. These fractions are not terrible. That if we got them to decimal form, wouldn't be too bad for us. So if you want to, if you're more comfortable with that. Obviously, if we had like 8 1/3, that's a repeating decimal, we wouldn't want to do this. But in this case, we can get by if we want. And I kind of cut to the chase here, but it says X weeks and amount of dog food used Y. So that kind of confirms that we did this correctly. 2 weeks, 8.5 cups. 5 weeks, 21 1/4 cups. So we've got them in the right order here. So if we're going to find our equation, first thing we need to do, we can find our slope. So change in y, if you want to start with your bigger y value, is 21.25 minus 8.5. And again, we got to go in the same order. So if we started with this y, we have to start with the x from that same ordered pair. So for the x's then, change in x, we subtract our x values would be 5 minus 2. When we do that, we know 5 minus 2 is 3, and in the numerator would be 12.75. Okay? Alright, and then we divide that. Alright, so 4.25 is our slope. And again, they're not asking us for this problem. A lot of times they like to do a follow-up question and say, what does the slope mean in this context of this problem? And then we just look at what our units are. Well, y was the dog food used in cups, so that would mean 4.25 cups, and we divided it by the number of weeks. So that means we're using 4.25 cups of dog food each week. Okay? So that's our slope. Now that we have our slope, now we need to find the y-intercept. So we're going to take our equation here. We're going to substitute in. We know our slope goes in place of the m. And then we have to decide which of these points we want to use. Well, neither one the greatest. Maybe if we had a pick, we'd probably pick something that didn't have decimals or fractions in it, but that's what we got, so we got to work with it here. So which point do you want to use? 8.5 and 2, okay. Alright, so 8.5 is our y, and 2 is our x. And then make sure you put them in the right spots for the x and for the y. So if we double 4.25, we get 8.5, and then if we were finding b here, we would have to subtract. They're adding, we subtract. So that would be 0. That means our y-intercept is 0. So we're starting out with no dog food used at the beginning. So this is actually proportional, goes 3, 0, 0. Okay, so if we have y equals mx plus b, we found our slope was 4.25, and we got our y-intercept is 0. Technically, adding 0, is that going to change anything? No. So if you wanted to, instead of that, you could just put y equals 4.25x for your equation, would work also. Example 3, graph shows the relationship of the height of a burning candle over time. What function represents the relationship? So if we think about our slope-intercept equation, we've got y equals mx plus b. So we take our equation, if we look at that, what would be our slope in this equation? Negative 1. What would be our y-intercept?
10.
Okay. Now, like we were talking about on that last problem, they didn't ask us to do it yet. We're going to look at, in this problem, what does that mean our slope is negative 1? What does that mean our y-intercept is 10? So they graphed this using their y-intercept. We could start there, right? Our slope was what? Negative 1. Okay, which means that's the same as negative 1 over 1. Okay, so from that y-intercept, how could we go to find another point on that line? Down 1 over 1. There it is. Okay, and then we can just draw a line that goes through that. That straight line, if we make a nice straight line here, use a ruler or something, that'll hit right at the point 10, 0. Okay, so what does this mean? Well, they kind of spell it out for us here. We can look at this, then we'll go through one together. That y-intercept means that the candle starting out 10 inches is the height of the candle. And then the slope was negative 1. Look at your units. We've got, it's changing y over changing x. So what's the y dealing with here? Height of the candle, okay? In inches. So down 1 inch, okay? Caden, what's the x dealing with? Hours, good. Okay, so if we just look at this, think about what our units are, we can see what's happening is the candle height is going down 1 inch every hour. Does that make sense? Okay, and then here, the x-intercept, which we haven't talked a whole lot about yet, but the x-intercept's where it hits the x-axis. That's showing us after 10 hours, the height is 0, which means our candle's burned out. Nothing left to it. All right, let's look at the try it then. Graph shows the relationship between the number of pages printed by a printer and the warm-up time before each printing. What function in the form y equals mx plus b represents this relationship? So a little different than what we just did on that last problem. This one, they're wanting you to come up with the equation here. So I'll give you guys a minute here, figure out the equation, and then have somebody tell us what that is. So we use this equation y equals mx plus b. Probably the easiest way for us to start out is to look at the equation and tell what our y-intercept is. Haley, what's our y-intercept here? 1. Okay, so the 1, where are we going to put that in place of in our equation? B, good. Alright, so we put a 1 in place of the b as our y-intercept. And then Jaden Wagner, what do we need to find next? Okay, how are we going to find the slope? Good. Okay. So did you use the points they've got kind of marked there, or did you use something different?
I used the 10 and
2. Okay. Use the 10, 2, and the 34?
Yeah.
Okay. So change in y?
2.
Good. And change in x?
4.
Okay. And this is the thing we got to watch. You're going over 4 blocks, but we got to look at the numbers there. They're not going by ones this time.
Okay.
20. Good. All right, so we got 2 over 20. Whoops. And that reduces to 1/10. Okay, now 1/10, remember, this is not the same as 10. If it was 10, it'd be 10 over 1. Okay, 1/10. If I have 1/10 of a candy bar, doesn't mean I have 10 candy bars, right? Okay, so our equation y equals 1/10 x plus 1. And again, they're not asking for us to tell what's happening here, but see how it says number of pages printed and the warm-up time? Basically, that warm-up time, sometimes when you turn something on, it takes a minute to warm up, and literally this is taking 1 minute to warm up before we start printing. And then the slope, we did minutes per number of pages printed. So that means 1/10 of a minute it prints a page. So what's that, like 6 seconds? 1/10 of a minute. So a key concept, again, just restates we've been talking about for a while, slope-intercept. M is our slope or constant rate of change. B is our y-intercept or initial value. So you look on 186, number 5. The data in the table below represent a linear relationship. Fill in the missing data. So linear relationship, we talked about earlier, makes a straight line. If it makes a straight line, our slope or our rate of change is constant. So slope is change in y, change in x. So if we just kind of look what's happening here, we can see the y values are adding 5 each time. So we can presume maybe if we add another 5, that would be 25. On the x's, what are they doing? Adding 10 means our blank here would be 30. Okay. And did we continue the pattern? Yes, we added 10 again, which is what we need to check to make sure that we actually did the right thing down here. Okay? Because if they, instead of adding 10 here, if we would have added 20, then we would have had to add more to our y value. But they actually did the same thing every time. Up 5 over 10, up 5 over 10, up 5 over 10 to make that linear. How could we check those points to make sure that we did that correctly? How could we make sure that that is linear? Graph them. Good. If we graph them, and they should make a straight line. If they didn't make a straight line, we made a mistake either here or on our graph. Technically, could be a possibility too, I guess. Okay, very good. All right. So number 6, they want us to write an equation that represents that linear function. So this is a little bit different than what we were doing earlier today, because we actually have 4 points. Earlier we had 2 points. Well, this is even better yet. This is like a buffet. We get to pick what's our favorite points to do the problem. Not quite like a buffet. We're not going to take them all, I guess, but we're going to pick our favorite 2 points. So which points do you want to work with here? 10, 10, and 20, 15. Okay. Again, if you picked a different thing, you pick different points, you actually will get the same answer. So we can label these. If we're going to find the equation, what's the first thing we have to do? We got to find our slope. Good. Which y value do you want to start with? Okay, we start with 15 if you want. It's the bigger y value. So 15 minus 10 means we've got to do 20 minus 10. Make sure you're getting this down. So 15 minus 10 is 5, 20 minus 10. And 5/10 is the same as 1/2. So 1/2 is our slope. Now that we've got our slope, we can find the y-intercept. So we can pick one of these points. Technically, we can pick any of the points again if we wanted to, but we'll just stick with what we got here. So which point do you want to use? 10, 10 or 20, 15? Okay. I would pick 10, 10 also, and I don't know if you guys thought about this or not. The reason I would pick 10, 10 is we can't really mess it up. X is 10, Y is 10. So as long as we don't put it in for the wrong letter, then we got this thing. X is 10, Y is 10. Okay, 10's a pretty nice number too. Alright, so if we just simplify this here, we've got half of 10 would be 5, and then subtract 5, good, would be 5. So we've got our slope, we've got our y-intercept. So taking the equation then, Nick, our equation would be
y equals 1/2 x plus 5x. Plus 5.
Very good. Y equals 1/2 x plus 5. And we don't really know what's happening in this problem, so we can't really say what the slope or the y-intercept mean.